Hello and welcome everybody onto the channel. Today I'm going to assemble one of these claw mechanics that is going to be used for KrustyBot. That is the robot that we have been constructing on the channel, and hopefully you like the design of it, and it is something that is interesting to look at. As you saw at the beginning here, is that it's actually fully functional, fully retracts, fully opens, and it has a good bit of gripability on it as well, as you can see entirely. Also, if you guys are interested on the KrustyBots here that I have available, these are available on our store, and they will be available for I was about to say they're going to be available for a limited time. They're always available, and we have limited quantities of them, of course, but we will have them in link in description. If you are interested, you can get yourselves available at bloomingcomet.com if you are interested. But without further ado, let's get started with this. So the first thing that we're going to start with is the creation of the actual designs for the claw device. Now, we won't be able to show everything that we have designed so far for the thing and step-by-steps on how we got here, but this is the raw files on how we did it. And just to give you a brief example of everything that we have done, here is the brief example of all the files, or at least every model that we have designed so far. Whether we use them all or not, that is up for debate, but this is a brief idea of everything that we are done. So just skip to the next part, basically just skipping to the actual printing process. Pretty much everything is going to be printed in either TPU or it's going to be printed in PETG. Let's see for those little peelies there, and that is going to basically help out with the printed parts for the claw innards. That's going to help with the gripping and also for the little clamping bits and gears, and also the pins as well as right here with the pin or the wrist part, but we had to get that out. So now we're going to start assembling the actual claw mechanics, or the mechanism that creates the actual claw that I have designed. And here we have the claw itself. Here's the body. Here's the claw innards that I called them. They have just a little bit of remnants inside. I don't know if it's viewable on the camera, but they're just a little stringy, but it's fine. The additional pins and things here, the accessories. This is technically called the wrist, but right now it's sitting inside of a bunch of supports, but we'll have to get that out here. That we're just going to set that aside for right now. Alright, so I had to do a little bit of organizing in order to ensure that the camera rig will not be in the way of assembling this thing, especially because I realized that I'm going to be hammering a little bit, and the camera is basically going to jitter every time this thing gets hammered. No pun intended. Maybe it was, I don't know. So anyways, let's see if we can get started here. So first what I'm going to do is start with the actual arms of the claw. So as you can see, you take the claw piece and we're going to basically just kind of set everything in here. The object was to try to make as few pieces that required screws. So I made it so that you can basically put all of these and kind of just slide it in. It's a little tricky at first, but as you can see, it slides right on inside. Alright, make sure that it's nicely lined up, kind of like that. And then there's one more. Now the reason these are divided is so that they are It's primarily for the grip, but also to make sure that they don't fail in between the actual printing, and because they're feathered pretty thinly like that, so it's just it's a precaution. So basically do it again, go in between here, kind of just fit it in between and press the thing inside just like that, and now it kind of sets like that. Now the other thing here is now we have the outer portion that is locked in, but now we need to set these inner pieces. Well, that's where these tiny pins come into play. And it's kind of hard to tell, but one end is slightly more tapered than the other. On the camera, it's way more difficult to see it, especially this 1080p camera, or this technically is supposed to be a 4K camera, but I doubt it entirely. But so this is supposed to go into these holes here. Now, depending if I did it correctly, it's supposed to go into the holes, and it's supposed to go and fit all the way through. Now, hopefully the camera doesn't start to shake around when I put it in. And gently tap it in so it's nice and level. Now we got it in there, and it's tapped very nicely inside. Now we basically do it all the way across with every single one. And just like that, all of them are set in place. And if you can kind of see in the light, nice little shimmer. They are all perfectly aligned, flush, and perfect. And it's set in there nicely. And now these feelers, or grips, whichever you want to say, are ready to go. And that's one claw side ready to go. And then we do it on the next side. Now, another thing that I would say here, it's like one issue that I've had that somebody would probably say, it's like, well, why, it looks really thin on this side, so why are you not concerned about that? And yes, I would say it is very thin right here, but the primary reason why I'm not very convinced, the reason I'm not too concerned on why this is a problem, is because this bending point is going to be interrupted by this giant piece of TPU right here. So that basically gets in the way and kind of acts as like a giant barrier and prevents it from bending too far. But of course, this is not going to grip too much, so I'm not that concerned. Like that. Now we have 2 claws ready for action and ready for the next step. Now, it doesn't really matter which one we start with, but we now have one base that needs the base plates put on, and we need to put in our next set of pins. And we're going to put the pins in first before we actually start putting in the actual motors. So we'll start by making sure that the pins are nice and set, and at least nice and flush. Now, of course, I probably should have made a little bit of a set screw or some kind of precaution in order to make sure that everything kind of was set, but to be quite honest, this project was taking a little bit longer than I was expecting, and it took a lot of brain power to get this far. Coming from an autistic person, this was really a lot of work and a lot of brain power. So, I know it may not seem like a lot, but it really was. So, okay. So now that these are in, we have our pegs. They're put into place. We're going to set these aside for now. We already have our servo motors. Now, I know these are a little bit older motors, but these are unfortunately the motors that I have. And I know that they're probably considered antiques to people, but they are still usable motors. And unless if they were, gigantic, motors that could be used on the market or something that people are just clamoring for, it's okay. So anyways, they just set in there like that. And what we'll do next is we'll just put in some screws in there to help hold these things down. So I'm gonna go get the screws and I'll be right back. Alright, I got the screws and I got my little handy dandy drill. Just going to put that on the end there. Probably could use a little bit shorter of a drill, but this will be fine for now. Make sure that's not too bad. That doesn't look bad at all to me. Now these are number 6 by 1/2 inch wood screws. You can obviously use machine screws, but I find that wood screws work pretty dang good. Now since this here has 4 slots, I'm going to just go ahead and put in the 4. Because why not? Also, a little bit of a side note here. After I put this last screw in, if you have empty pill bottles, I recommend you take the labels off and mark them with just take a Sharpie, and then that's a good little thing to hold your screws. Really useful. Anyways, okay, so now we will take a couple of washers, put them in. Oh, another thing I forgot. The big ones, I totally forgot. I needed to get these oh man, I'm so dumb. This is where ADHD and autism are just totally in universe. They don't mix well. Ball bearings. These are very important for this thing. And it's like, oh, you're done. No, you're not done. You are so not done. These tiny little ball bearings are absolutely required in order to make sure that this thing works smoothly and efficiently. Take these and you press them in. If you have a little struggle, just a little clamp will help you. Next thing you know, take this, push it in. Oops. Don't want that to pop out. Pop that in. Now, next thing you really want to do is, if you have your RC controller, you want to plug this in to make sure that your settings are at their, basically, I guess you would say at their 0, or what have you, so that you don't necessarily destroy your motors or destroy your controller. So I'm gonna go get my controller and I'll be right back. Alright, so I already got my controller and I got a battery. This is basically a FlySky controller, and it is with a 10 channel receiver. And now I have it connected to the little servo. It's basically connected to the switch up here. And basically what we're going to do is we're going to have it set to the up position. So that is basically set to 0. And then we're going to insert the gear. We're going to find the best spot for the gear. And now, just like that. And now we'll figure out the rest of the stuff later on, but usually the best way to do this is kind of to go by eye. I'm sure that there will be more other comments on like better placement or things. And if you do have better better advice on how to set things up like this, then I do welcome it. I am pretty much an amateur at this type of stuff. This is my first experience at actually doing things like this. But this is kind of better. So as you can see, with minimal effort, it does open and close. So that gear is actually in. That's good news. So that means we're done with that. Alright, next thing we need to do is to assemble the next plate. And this plate basically goes on top and it houses the second motor. This allows for the claw to have double the strength rather than single strength on just one motor. Now it has to be placed like this, but we cannot have it like this or this. So we need to flip it upside down and insert the motor just like so. And pop her in. Come on, you. You're going in the hole. That's right. You're gonna go into the hole. Of course, sometimes these motors don't want to go, but it's okay. They do just enough of a fit just to go. There we go. Next, we're going to go ahead and drill these in because we can. Oops. I don't know if you can hear anything upstairs. Cats are running around. Little buggers. Okay, that's done. I'm finished with these screws here. These aside. Now, next thing before I forget, I have these little spacers to make sure that they don't go very far down when I set this, and I also have this that goes into place. But the next thing we're going to do is we're going to just ensure that the gear essentially is in the right space before we assemble it all together. And we'll do that basically by just using the motor just like before and just connect it. So for me it is channel 10, and we just turn on the receiver or transmitter, receiver, yes, transmitter. Turn on the transmitter, turn on the receiver, make sure that it's all working. plug in the gear, but do not put it all the way on. It should be, yep, just flush with the gears. So, oops. Let's try that again. Uh-oh. Oh. God dang it. So I realized that I'm a bit of an idiot. I forgot that you actually have to wire up both of them at the same time, so both of the motors have to be hooked up to the same channel at the same time. So here's a Y harness, and this is going to connect both servos onto the same connector at the same time. This should help to alleviate that problem, because one of the gears was rotating, but it was kind of making the gears grind. So that was smart, sir. Very smart indeed. There. Now we just let that kind of float. That should be okay enough. Please do not break. Yeah, that's better. Okay. That's much better. That's what I wanted. Okay, now we can move on to the next part. This is unfortunately the part that I dread the most sometimes when it comes to these builds. This is a custom part that I had designed, much like all the other custom parts. But this is important. This is the wrist of the claw that I designed. But right now, as you can see, it's encased in support material. This support material is PLA, and the model itself is made of PETG. Now, how do you achieve this? Well, thanks to my printer Squid, which is actually a Prusa XL, it is able to print these. Now, what's the reason of doing something like this? Well, the reason is for the layer lines, because you need to make sure that layer lines are the main downfall for any 3D print. If anybody who has done 3D printing knows this exact thing, they know that a 3D print will fail the most at the layer lines. So the best thing to do, especially for something that has a lot of strength, or something that requires a lot of strength, is to make the forces perpendicular, or basically have the forces perpendicular to wherever the actual layers are, rather than parallel to the actual force. The same premises for this. Of course, because this part is so complicated, I basically had to orient it in a way so that the material could be printed, but also so the support material could be get into all the regions inside. But this is probably going to be the most boring portion to watch, so you might see this part sped up a bit. So, yeah, this is going to take a little bit of time. Okay, and just like that, just as I have expected, here's the part. Sorry about that. That took a little bit longer than I was expecting. Not as before, since I've already tested this part. There are, of course, little bits and pieces there. However, this does kind of help showcase my hypothesis a little bit, as I had suspected, and as inevitable as it happens. This part did unfortunately break in the process as I was taking it out of the supports. So it's a little hard to tell, but there is a slight hairline fracture across there. I don't know if it is possible to catch it on camera or not, but it is very small. It's right about there. But as you can see, it would be in this direction. So, if anything, the only place it would actually affect is in this general area here. It wouldn't affect the majority of the entire print on itself. So, that kind of helps to prove my hypothesis, which is that if I had printed it in the traditional sense, it would have just broken apart. So in this case, the outward forces that were exerted would not break in the traditional sense. So, in fact, I think you can see the layer lines in a more traditional fashion if I show you like this. Exactly. I would certainly hope you can on this camera, but that's what happens on this cheap camera. So anyways, time to put in here. So this joint basically fits snugly in the center. Oh, but make sure that this hole is faced out, and then it fits in there just like that. And then the next thing that is important is we face, we'll come back to those. You fit the cables through this. You don't have to fit everything through there, just the bulk of the cable, and fit it through that hole. Because unfortunately, yes, my splicings will fit. They will not fit all the way through, and that's okay. These things are old. They had old connectors that I had to unfortunately splice in order to get them. They are wired, or I did solder them, so it should be fine, and they should be perfectly protected. Okay, and then we are going to go ahead and do kind of the same thing here, although this one may have a chance to actually fit through this hole, perhaps. Yep, just like so. Of course, it's important not to pull too hard. Then fit it through the hole. If you need to fish it, we'll fish it out later. Okay, and then now is the final part, which is to connect all the parts into the housing, like so. We may need to give just a little bit of encouragement. Oops. The only downside is making sure that everything fits nicely and goes on there correctly. That should go nice. That's good. Number 3. And number 4. Nice. And just like that, that is a completed jaw. That is one completed claw. And if we hook up the harness to our 2 wires, complete the circuit to the battery, turn on our transmitter, and there you go. And it works like a charm, just like that. Now, of course, this is not the end of this project, but it is the next step for my Krusty project. But this is, of course, going to be the next step for adding on to him. Now, the next thing will be obviously to add a piece of PVC pipe in order to, excuse me, to add on here so that it makes it a more skeletal function. But then also we'll add the shell design so that he'll have a little bit more meaty claws so that he looks a lot more robust. But given how he looks now, its grip strength is actually pretty good. Well, of course, you gotta aim it, and it's good strength. And this is why you need actual LiPo batteries rather than just 4 AA batteries. But this is fine. And 4 batteries is okay. But 2 servos definitely made a difference. And of course, you know, I'm pleased with it, especially for just cosmetic purposes or whatever. But anyways, that's it. And I hope you enjoyed that. And if you'd like to follow up with more shit, with more of the progress of Krusty, keep a follow, subscribe, like this video, add it to favorites if you like it, and see you in the next one. Peace.